Today we're going to talk about the new release of MSC Apex, which is 2020 Feature Pack 1. Let me get rid of this little thing there. There we go. And before we get started into the agenda, I just wanted to remind everybody that everyone's on mute by default. We'll reopen it audio-wise so that you can unmute yourselves during the Q&A portion towards the end of the webinar. We also have a poll going. During the webinar, please, when you get a moment, it only takes a couple of minutes, go ahead and fill out that poll. There's only 6 questions there, so it's nice and quick. And it asks things like, are you using Apex currently? And if so, what are you using it for? It's for market research, and that way we can see what it is you're working on. Okay. So today's agenda is a 6-parter. So first, we're just going to do a high-level overview of what Apex is and where it's at in the market currently. We're also going to introduce our 2 speakers, me, James Pira, as well as our product manager, Mitch Muncy. We're going to give you a very brief introduction of what is new in our generative design product. Now, that is a separate product inside of Apex, so this is just going to be a high-level overview of Apex generative design and not the full deep dive that will come later when the GA comes out for Apex generative design. But today's focus is specifically on Apex modeler and structures. Then we'll talk about the details of what's new inside of Apex pre-processing, inside of Apex modeler, as well as MSC Nastran interoperability. And then finally, we'll finish up with what's new in post-processing, as well as what's new in the Python API scripting capabilities. So to get started here, I just wanted to introduce the 2 of us here. So I am James Pura. I'm the product marketing manager of MSC Apex. Some of you may know me from my previous role, which was business development inside of North America, and so Canada, US, and Mexico. And I'll hand the microphone over to Mr. Mitch.
Yeah, thanks, James. So I think where I want to start with this one is, if you think that we feels like we just did one of these a few months ago, that's because we did. So I'm really excited. We rolled out Apex 2020 at the end of April, and here we are about 3 months later. We've got our next action-packed release available. So I'm really excited about this. We're going to keep rolling these out at a high velocity. I know many of you on the call are kind of have your hands tied when it comes to getting your hands on the latest versions, but that's not going to stop us from trying to get these out as quickly as possible and allow you to make the choice of when you want to take that next release, because we know there's a lot of new functionality. Our teams operating at a very high velocity, so we want to make sure that we get that out there as quickly as possible, and then let you get your hands on it as quickly as you can as well. So like you'll see in James' presentation, we've got a lot that's been packed into this release, and I'm very excited to show you. And then the last thing I do want to mention is welcome James to the team, because many of you know James. He's been the voice of our customer for many years. He's got a tremendous background in CAE and especially Apex, and a lot of the new functionality that we're presenting today are part of his hard work. So I'm really excited about having James as well. So as that said, feel free to ask questions. I'll be online answering questions if you have anything, and then we'll look back at that at the end as well. So with that, I'll hand it back over to James.
Thanks, Mitch. Appreciate it. All right. Well, let's just let's keep going then, and talk about how is Apex being used today in the field. Okay. So by customers around the world, geometry is category number 1. Where people love and actually buy the product specifically for its geometry capabilities. Now, this includes the defeaturing capabilities, which this release actually has some brand new capabilities there for defeaturing, but also things like sketching, geometry repair, and basic CAD operations like revolve, extruding, sweeping, and lofting. So, and this all kind of ties in with the fact that, let's say you run a stress analysis and something goes wrong, right? Your margin of safety is not what you think it was going to be, but your engineering intuition tells you what you need to do in order to change it and make it better. Well, Now you can make that change specifically inside of Apex without going back and starting all over from brand new CAD. Now, category number 2 is how is Apex being used today for meshing? Well, we're very proud of all the meshing algorithms that go into Apex, and this release actually has some nice improvements as well regarding our meshing algorithms for both shell meshing and tetrahedral meshing. But things like hex meshing and being able to diagnose why it's not able to be hex meshed, or just having immediate feedback on which how to mesh things like automatic washers around fastener holes, things that we wish that we've had for the last 20-30 years, and finally now Apex has stepped up to the plate and delivered those technologies that we've been asking for. So people love and use Apex for that specific purpose. Now, what about design trade-off studies? Now that's category number 3, where it really doesn't matter what type of analysis that you're doing, whether it be linear static, buckling, frequency response, or number of modes. The ability to change your model right on the fly and be able to view and compare and contrast results based on those changes without doing any type of new model building from brand new CAD is a big deal. And our customers around the world are saying so with 13, 14 different languages around the world. The ability to not just use the integrated solver inside of Apex, but also use Apex as a pre and post processor to MSC Nastran has really sped up the workflow for doing things like design trade-off studies inside of early design phase. Now, kind of the new kid on the block, but is a powerhouse of technology, is the interoperability with the first of what will be multiple solvers inside of the MSC portfolio and elsewhere, which Apex now supports orphan mesh workflow, which previously some of you may remember when Apex only supported a CAD-based workflow, right? Well, now you can import a Nastran bulk data file and either just run it on the fly, or you can back calculate the geometry from that mesh and make modifications just like you would if you had started from the brand new CAD. And that's a really big deal. It's never been done before in any other FEA tool, and we're very proud of it, and our customers are very excited about it. Also, just the ability to import Nastran results and view the results. You don't have to run it internally inside of Apex first. Customers are importing those Nastran results, especially if they have linear statics, buckling, or normal modes analysis, and they just want some very quick results viewing. You can do that inside of Apex. Now, also I'll tack on the fact that customers are also using the interoperability with MSC Nastran, not just as a pre-post, but also they're leveraging the Python API in order to do things that I'll get into a little bit later, but it's also very, very exciting. Now, people are using Apex also for generative design. Now, what is generative design? Well, we have a whole webinar that explains that previously. So if you haven't seen it yet, go back to our website, mscapex.com, or straight on our homepage. You can navigate to the Apex side and watch that. But at the end of the day, if you are 3D printing anything, whether it be out of metal or polymers or fiber reinforced composite or anything, you can, if you're printing it, you can validate that design by not only validating it with the print build and thermal distortion, whether it be DGNAT or SimUvac, but you can also start in the very beginning by doing a full topology optimization and getting very rapid design candidates. Now, what makes this different than everybody else? Well, that's what the webinar is all about. So please feel free to go watch that. But it's a very exciting time, and our customers are telling us so that they love this tool. So I guess let's get right into it. It looks like we've got a comment that says any audio. Yes, we are talking. And just another quick audio check. Mitch, are you still hearing me loud and clear?
Yep, sounds good.
All right, great. For those of you that don't have audio, please feel free to either call in or use the link directly. But let's just get right into it. What is new inside of Apex Generative Design? Now, keep in mind that this is just a high-level overview, okay? Also keep in mind that this is only the second release of Apex Generative Design. Okay, so we now have the ability to deliver remote loads. So let's say you're putting a force in between two bolt holes. Maybe you want to you don't want to model in the actual CAD of the lug that you're putting in, but maybe it's a lug and clevis assembly, and you just want to put the load in where the lug used to be. And you can do that now. You previously couldn't in the very initial release, and this was something that was very high on our list, and we have now delivered it. Now, also what came back from feedback from our customers was surprise. When they were running their initial topology optimizations, they were realizing that the algorithms that are built into Apex Generator Design was telling them that they didn't need all the fastener locations that they previously had. And you can see an example of that, of an optimization on the right there, where all of the stress constraints were met, all of the design criteria were met, and the design was lightweighted to the point where it met all needs, but it did so by reducing the fasteners from 4 to 2. And that kind of turned some users off, and they were like, wait a minute, I like my fastener holes and I need to keep them, so give me an option to keep those. And sure enough, now Apex Generator Design now supports that. Now, granted, the caveat is that you're going to get a heavier part then maybe you'll get a heavier part than what you would do if it was fully optimized. But that is your design prerogative, right? You can definitely do that if you want to. Now, the other bit of feedback that we got from the field was that when you were running an optimization inside of Generator Design, one of the cool parts about it is that once you're done with the optimization, you can then export complete geometry that then you can bring into Apex Modeler and mesh and do a full finite element analysis on that. But one of the things that the bit of feedback that came back was, even though that technology was amazing and great, you got things like the picture on the far right, where you get these rounded corners and these fillets that previously weren't there. And instead, people were asking for the sharp corners that came with the original non-design space. And so let's say you wanted a washer that was fully perfectly round with some sharp edges on that. Well, now we have automatic intersection built in that allows you to do that. So the moment you export geometry, it immediately does kind of a Boolean operation with the original non-design space and make sure that you got those sharp surfaces and sharp corners that you originally had. Okay. And then the last thing, now this is a development on the Apex Modeler piece, but very much ties into the Apex Generative Design piece, which is the ability to export geometry that has already been optimized inside of Generative Design and bring that directly into Apex Modeler, so that then you can do a traditional FEA analysis on this. Now, that handoff, even though it was supported in the first release, it was more of like a two-lane highway in the countryside, right? Well, now we've turned that two-lane highway into kind of like a four-lane freeway in the middle of the city, where now we have the ability to export an FTL or a mesh, and you can bring that directly into Apex Modeler and turn that into NURBS geometry if you'd like to. So that is kind of some voodoo science. Every time I see it, I can scarcely believe that that's actually a reality, but it's a lot of fun to play with. So I highly suggest that you do. So let's shift gears a little bit and let's talk about Apex Modeler specifically, okay? And in particular, let's talk about pre-processing, which is really the user interface or UI, geometry, and meshing, those three subcategories, okay? So now the first one we're going to talk about is a brand new introduction of a light theme. Now, the general software industry as a whole has gone to this light and dark mode, and the FEA industry is no different. So we wanted to support that kind of like that modern software approach where users can choose which interface that you want. Now, the version on the right was the original, the OG version of Apex, where it's easier on the eyes, it's more visibility of your model. The background kind of fades away so that it increases focus on the actual part that you're working on. Well, some users wanted additional accessibility and readability by increasing the contrast, and we wholeheartedly support that idea. So on the left here, you can see that, that we now have a light theme and a dark theme inside of Apex, which is pretty exciting. Now, we also have, in the distance tool, we now have an ability to measure the X, Y, and Z components. Now, this has been a long-standing request, and we're very proud to deliver it to you today. So now, not only do you get the relative distance between two locations, but you also get the X, Y, and Z components. Now, another long-standing request is the ability to define the rotation center on your part. All the current users of Apex that are on the phone today know that Apex automatically grabs whatever part of your geometry is closest to the center of your screen, and it rotates around that location. Well, now you have the ability to just click on a certain part of your model, and Apex will automatically rotate around that part of your model. So that has been a breath of fresh air for some of you, I know, that have been waiting for quite a long time for that technology, and we're very proud to deliver it to you today. Okay. Now, the next technology that that we're delivering to you is a curves tool enhancement, where let's say you have mid-surfaces that that you're editing, and or maybe some geometry cleanup where you're missing some surfaces, or you have some facets that you need to fix or something like that. Well, now the curves tool fits right in, because the way previously that you would do that is basically deleting the surfaces, rebuilding the curves from scratch, and then maybe using the filler tool or something like that in order to rebuild those surfaces. Well, this kind of speeds up that operation by allowing you to project lines onto surfaces, extract the curves from the edges of a surface, as well as intersecting planes. You can extract the curve from that intersection as well. Now, probably one of the most exciting things to happen to the Deep Feature tool since it very first came out is now the fact that you can actually drag a box, and this is kind of voodoo science to me also. Every time I see it, it makes me smile, is that you can actually just drag a box around an entire set of logos or an entire set of lettering, and it immediately disappears. Now, this is kind of like voodoo science. Every time I see it, I scarcely believe what I'm looking at here. And that's the reason why I've set up a demo so that you guys can actually see it. All right, so the first demo that I'm going to show you is our little friend, the turkey here. Now, in a few months, assuming COVID allows us to all get together with our families, at least here in North America, we'll be sitting down to the Thanksgiving dinner table. And a lot of us will be arguing with our family and friends over who gets light meat and who gets dark meat. Well, now in the FEA world, you no longer have to have that argument either, because you have both. You have both light mode and you have dark mode, okay? So whichever side of the table you want to sit at, no matter what color or background shade you want Apex to be at, you totally can. And you can even make your turkey dance a little bit by defining the center of rotation as well. So you can see an example of that, where I'm clicking on the bottom right-hand corner there, and our turkey's dancing around the bottom corner of that piece of CAD geometry, okay? All right, so getting a little bit more serious now, though. Let's go into that voodoo science of defeaturing technology. Let's look at the latest and greatest of that. Now, here we're looking at a section of a casting. And if I go into the defeature tool and I choose the option, the brand new option of select geometry manually, I can just drag a box, and it doesn't even matter if I drag it over another section, whether it be other fillets or other chamfers or anything like that. It will automatically locate that lettering and that logo, and it'll automatically defeature it and repair the geometry like if it wasn't even there. And so here's another example of a gearbox cover, where I just drag a box and it automatically locates the lettering and it defeatures it right off the bat, okay? Pretty exciting stuff. So if you guys have any castings that you're trying to do some geometry defeaturing on or some cleanup on, we got you covered there. Now, some updates in meshing for specifically 2D meshing. We have this new technology called mesh flow optimization, This really kind of brings Apex to the grade A standard of shell meshing that we wanted it to be, where it actually has the ability to identify geometry features like curves or waves in the geometry, and it'll line up the geometry with those geometry features. And you can see an example of that. And this is just a very simplified version of this, but we wholeheartedly suggest that everybody on the phone use mesh flow optimization, because chances are good that you're going to get a much better mesh if you do. Now, because this is brand new technology, we decided to not change this to the default behavior. We probably will in the future, assuming all goes as planned, or we might. I don't want to promise anything on the phone here while we're on this webinar, but there's a good chance that if all of you guys and gals are using Apex and this mesh flow optimization technology is going the way we want it to, there's a good chance that this will replace our default meshing behavior. So feel free to go ahead and use that moving forward. Now, also in the category of meshing upgrades, we've upgraded our tetrahedral mesher. We now have the ability to manage the growth rate. And you can see examples of this in these 4 pictures. The default behavior is something that we are used to. Since Arctic Wolf, tetrahedral meshing has been supported, and here we are 11 or 12 releases later, and now we have the ability to take tetrahedral meshing and not only do everything else that has been enhanced over the last few releases, but also we can actually manage the growth rate. Now, this is in addition to the fact that Apex still is optimizing your mesh for the geometry that you have in it. This just gives you one more level of control so that you can manage that growth rate of your tetrahedral mesh. Now, also along the topic of tetrahedral meshing, you have the ability to snap those mid-side nodes to a curve. Now, this has also been a long-standing request for people that were frustrated with the fact that their mid-side nodes were kind of floating, and you can see the example of that on the cube that's on the right-hand side that has a fastener hole through it, and the mid-side nodes are disconnected from the interior surface of that cylinder. And on the left-hand side, you can see now if you check that box and then you mesh your part, that the mid-side nodes will actually snap to the geometry that's provided. Okay, so a little bit more dial, and you can dial in your mesh the way you want it to. Okay. Now, on the topic of orphan meshing, now what is orphan meshing, or other people call it dead meshing or something like that? This is where you're importing a mesh that does not have any geometry attached to it. That's the reason why we call it orphan meshing, because it's been orphaned from its original geometry, right? So now we have the ability to create facet bodies from that orphan mesh. But up until Apex 2020, we did not have the ability to wear connectors. If you use that facet body to recreate the geometry, and why would you recreate the geometry? Probably because you want to remesh something, or as part of your process, you wanted to change something. Well, if you made that change, your fasteners would get blown away. They would not update along with everything else. And that has now been fixed. So now, and this is actually a very painful situation that has now been resolved inside of 2020 Feature Pack 1. And it's so cool that I even wanted to include a demo for you, and I wanted to show it to you. So here you can see I am actually going to import a bulk data file. And I'm going to choose the option of import by contiguous mesh regions, just so it's nice and colorful, because we got a nice, fun demo here, and I want to make sure that you guys can see that we have multiple parts that are connected inside of an assembly. So here is our assembly with lots of fasteners connected to it. Now, keep in mind, this is an orphan mesh. This is a Nastran bulk data file. Now, when you import it, this is kind of old school technology because it's been around for 2 or 3 releases now, but Apex actually realized that they're connectors, and it actually labels them as connectors now. But the new technology here is that I take that top surface and notice that and this is Apex 2020 that we're looking at here. This is not 2020 Feature Pack 1. Notice that I am going to recreate that geometry, and then I'm going to remesh that faceted geometry. Watch what happens to those fasteners. Boom, they're gone. right? And notice that in the model browser, it even validates the fact that they're gone. If I expand it, notice I've got these little red X's, and if I scroll down, I've got some like exclamation points and some bushings that are not looking very good. And now, you know, if I was in Apex 2020, I would have to go rebuild that. Well, let's hop on over to Apex 2020 Feature Pack 1, and let's do the same thing, the exact same workflow. And let's show you that, that enhancement now. Okay, so there is our imported Nastran bulk data file. I'm going to turn off this coordinate system, zoom in a little bit to our part. All right, there's our connectors. All right, so so everything's hunky-dory right now, but now let's go and try and mess with it a little bit. Let's create geometry from that mesh, and let's now that we're going to extract that facet body. Now we're going to go in and we're going to modify that by remeshing that part. And you can do the same thing by reseeding or something like that as well. But notice that now that I've remeshed it with totally different element size, now all of my connectors are intact and they are good to go. So now Apex is behaving the way it should and the way people expect it to, which is just everything's generative and you never have to go back and redo any of the work that you previously did. So that's in line with our whole vision of the product. So that is what's new in pre-processing. Now, if you're not wowed already, get ready for your jaws to drop on the floor here, because we've got some really cool stuff when it comes to Nastran interoperability. Apex 2020 Feature Pack 1 now supports contiguous mesh across parts. Any of our powerhouse Nastran users that are on the phone, and I know we got lots of them, on the phone today, know that Nastran has the ability to allow nodes to be shared across different parts. Well, up to and including Apex 2020, we did not have the support for that. And that caused all sorts of problems when you imported those Nastran models into Apex, and all of a sudden they were disconnected. Well, now we have the ability, and this was a very large project, and behind the scenes, it seems like such a simple solution, but it touched so many different parts of Apex, and we're very proud to deliver this to you today, so that now nodes and elements can be shared by multiple parts. Now, here is an example of what happened in Apex 2020 when you imported that bulk data file. You can see that I've got my little airplane, and it's such a sad little airplane because it's all disconnected. You know, its head is disconnected from its body and its tail, and its wings are not connected to the fuselage anymore. Oh man, that's a very unhappy airplane. Now, what happens when I go over to Apex 2020? Well, look at it dancing right there, right? It's a happy airplane. Now it's all fully connected. It's just doing the jitterbug over there because it's nice and happy that all those shared nodes are fully connected and shared across multiple parts. Okay, so there you go. If anything, you can pull away from the fact that MSC gives you videos of dancing airplanes on PowerPoint slides. That's an exclusive. All right, so the next big Nastran interoperability technology is related to beams, and this is 1D elements where previously in 2020 and earlier, you had one edge and one surface for each beam span. And if you can imagine an airplane or a ship or a car that had lots of beams attached to it, you can have thousands or even tens of thousands of these beam spans, which from a data standpoint is very inefficient. You have an Nastran bulk data file that is way bigger than it needs to be. You also have lots of time and effort that it takes in order to modify and even create a model from scratch. And now you have the ability to have multiple edges belong to one beam span. And this also means that they're auto-aligned also. So if you change one, it all kind of changes all along with it. Now, this in and of itself is kind of cool, especially when you can look at the different colors on the left-hand side, and it's all one color on the right-hand side. But where it really matters is examples like this. And we wanted to show you two just kind of standard industry examples where this technology really hits home. On the left-hand side, you can see the shipbuilding industry, where a lot of the ship hull stiffeners are modeled using beams. And this is where the longitudinal beams, imagine clicking one each curve one at a time, and man, it would take you hours in order to model a ship like that. And I've done it before, believe me, it takes you hours, sometimes even days in order to model that with the one click per beam technology. Now, in aerospace, it's no different, right? You've got lots of longitudinal stiffeners and longerons and all sorts of things inside of your wing and your fuselage that require beams. And in order to show the power of this new technology, I figured we'd give you a demo of what this looks like. Now, this is Apex 2020 in its glorious dark mode, okay? And here I've got my ship model, my cargo ship, and I've already got a beam, a T cross section that's already created. And what I'm going to do is I'm just going to look at that ship hull itself. And I'm just going to create a few beam stiffeners just to show you how painful it was before Apex 20 Feature Pack 1. It was fun if you're creating 4 or 5 or 6, but when you're creating 4 or 5, 600 beams, it can be tedious and time consuming. So here we're going in and we are creating beams the way it was circa Apex 2020, and we click on one edge and one surface, and we rotate around, and there is our stiffener beam. Okay. Now let's do it again. There you go. And let's just keep on going. There's number 3, and then there's number 4, and number 5. And if you see, if I pan out a little bit, you can see how long this would take you if you wanted to create beam stiffeners for the entire ship. Now let's hop on over to Apex 2020 Feature Pack 1, and let's do the exact same thing. And let's make it a whole lot more fun and simpler and just more efficient. Right. So again, we've got our cross section, and we're in light mode now too. So let's just go ahead and create that same beam stiffener by, I'm going to do an Alt double click on that edge, and then I'm going to do an Alt double click on that surface as well. And notice that when I execute that beam span assignment, and then I rotate around as soon as it's done here, there we go. Notice that beam span has now been created during the entire length of that ship. Okay, the entire length of that curve. And now I can just go ahead and mesh that edge, that curve, and I'm off and running. Okay, so now let's look at an airplane example, which for some of you hits home a little bit more. So let's look at maybe the door surround, the section that goes around. We all know that there's lots of stiffeners that go into a fuselage, and if I'm modeling this, maybe a little hat cross section. I've already got my stiffener created. And again, let's do this in Apex 2020, right? So I create a beam span and I assign it to one edge. There you go. And my offset is already correct, but still I need to click on one line at a time and one surface at a time, which you can see that this is just one section of just the fuselage section of the airplane. And this can take quite a long time. Hence why people were using scripting in order to automate this, because it was a very long and repetitive process. Well, now, if you don't know Python, that's totally fine, because now we've got this much faster process that is capable of handling this multi-span beam assignment, where we have a span assigned to multiple edges. I apologize. There's multi-edges, not multi-span. So one span per edge, we can double click and just to kind of show the power here. In the same amount of time that it took for me to assign that one length in Apex 2020, I'll just go ahead and finish the entire model here, the entire door surround panel, and there you go. I have now assigned beams to the entire section, and now all the offsets and everything is good to go. Now I'm ready to go mesh and run a NASTran. Okay, so there is your multi-edge beam span technology. Very happy with it. Now on the NASTran performance itself, we have made some improvements under the hood also. So you're just going to see things happen a lot faster. And the example of that is that if you import a NASTran bulk data file, just one small example is we had a very big full vehicle aerospace model inside of Apex 2020 that had thousands of materials and properties assigned to it, right? And we imported that into Apex 2020 before all the improvements were made, and it took 368, almost 400 seconds. Now we basically cut that in half in the new release of Apex 2020 Feature Pack 1, and also the NASTran post-processing import performance is also improved by about the same. It's basically cut in half. So things are just going to be zippier and faster, and we got you covered in terms of time savings and efficiency. Now let's talk about post-processing, and then we're going to finish up with Python, and then we'll go into some Q&A here. So let's talk about what's new in post-processing. So this has been something that that customers have been waiting for a while, and we are proud to deliver it to you today, which is we can finally support post-processing remote constraints and remote forced moments. So let's say you want to do a force balance equation, right? You want to do an analysis where you apply a load, you want to see the equal and opposite. Well, in Apex 2020 and earlier, that totally was able to be done, but you needed to apply the constraints directly on the model. You could not actually post-process the constraints if they were remotely applied. Well, it just so happens that a lot of the constraints that are applied are on fastener holes, right? So you need to create this remote constraint and connect it to the center of the fastener hole, which there's no elements there, right? So now you have the ability to post-process remote constraints and remote force moments. And this happens both with the internal solver as well as post-processing. MSC Nanostrand is the exact same behavior. So we got you covered. Now, from also on the topic of Nanostrand interoperability, you have the ability to not only import your BDF or your HDF5 post-process results, you also have the ability now to import both of them at the same time. So more along the theme of saving time and saving effort and reducing the repeating tasks that FEA engineers have to do on a daily basis. We have, in that spirit, we have supported the ability to import both HDF5 files and BDF files at the same time. And you just have to click on import once. Now, also, finally, we have the ability to import normal modes Sol 103 mass matrices. This is something that just didn't quite make the cut when we first delivered the ability to support Sol 103 Nanostrand importing, and we're happy that we can finally finish that project and deliver that technology to you. The gap is now closed, as they say. Now, some additional minor enhancements that will likely hit home for you guys is we now have the ability to do smart averaging in post-processing. Now, this is something for our Patron users that have had this capability for a while now. You now have this ability inside of Apex also. And then if you do frequency response dynamics, you will very much care about this final minor enhancement that we now have the ability to plot magnitude, phase, as well as real and imaginary results. Okay, and you can see that all in the same plot. An example of that is in the bottom center of the screen there, where you can see all four plotted at the same time. And just like everything else inside of Apex post-processing, it's just a pull-down menu where it's nice and easy and everything updates right on the fly for you. Okay, so in order to demo that, I'm going to demo the two coolest technologies that I thought would be really fun to demo, which the first one is remote constraints. So here I've got just a very general piece of geometry where I've got four fastener holes that I'm going to bolt to the ground, and I've got a fastener hole up top there that I am applying a load to. So notice that if I double click the force, you can see that I've got 100 newtons pointed in the positive Z direction, okay? And I've got four constraints applied, and they're remote constraints applied to the centers of all four bolt holes, okay? Now, engineering intuition says that if I post-process this, I should get equal and opposite reactions, right? So if I add up the Z reaction forces of all four constraints, I should get close to or equal to 100 newtons, okay? So I've already run this, and I'm just going to go and enter post-processing, and I am going to verify that I now have that technology, okay? Also, just note that I'm in dark mode, even though I'm in 2020 Feature Pack 1. I just really like it in terms of comparing the rainbow plots. It demoed a little better, so forgive me for not sharing the light mode for post-processing here. Okay, so all I have to do is in my post-processing, I just double-click constraints, and notice that when I double-click constraints, notice I have constraint reaction forces and constraint reaction moments that I can turn on the vector plot on. And in the menu that pops up, I'm just going to click on Z component, and remember what the load was that I applied. It was 100 newtons in the Z direction, right? So I go into the visualization tab, and let's just make the arrows a little bit bigger so we can see all 4 of them. Let's just move that slider bar there. There we go. Kind of cartoonish type of size of arrows, but at least you'll be able to see all 4 of them. Okay, and then we're going to turn on labels. So we're going to look at all 4 of those, and sure enough, voila, we add all 4 of those up. We got 50, 50, a little bit over 50, and a couple of -2, and we add those up, and sure enough, we get a total of 100 newtons. And magic, we now have the ability to post-process remote constraints. So very proud of that. Now the next demo is a very quick one where basically you have the ability to import both the BDF and the HDF5 results. So you go to import FEM. Notice that the import section is grayed out right now. It will pop up the moment that you actually choose the HDF5 file. So notice that now I have this static scenario. I can import that HDF5 file, and now that pull-down menu has the ability to change it to both model and results. And it'll just go ahead and pull that BDF at the same time. And then I click on import, and notice that it immediately jumps to pre-processing, where there I'm looking at my bulk data file. And let me close that, and then I can go directly into post-processing as soon as I verify, yep, that's my model. And then I go to the Studies tab, and lo and behold, now I no longer have to right-click and say import results. All I have to do, it's already imported. Now I just have to, just like normal, I would just right-click and say post-process as if it ran internal using the built-in solver. Okay, and there are my results. So we're good to go there. Okay. All right. Now let's talk about the very last step, which is Python API scripting, and then we'll jump into some Q&A here. By the way, just as a reminder, I know we're getting close to the end here, but if you guys haven't filled out the poll yet, please click on the poll in the bottom right-hand corner and fill out those 6 questions for us. And then also, if you have any questions that have been boiling to the top of the surface, feel free to enter those into the chat window if you haven't already, and we'll address those here in a little bit. Okay, so let's talk about Python APIs and the latest and greatest when it comes to scripting. So the new features that are available both manually are now available inside of Python, so automatically as well. So things like geometry curve modeling and NURBS geometry creation and measuring distance components, rotation center, all of that stuff now you can control using the Python API. Now, some things that are not in there yet, but we're still kind of tweaking and making better are generative design capabilities and incremental surface meshing. So that will be coming very soon. Now, for advanced users, that's kind of for the basic users. For the advanced users, you know, we've got some people on the call today that really push the limits of what Python is capable of inside of Apex. I've seen some really just magic looking stuff, and we're very proud of all of those users, and we support you guys with some advanced users as well, some advanced technologies. So 2 of those advanced technologies, the new advanced technologies are the meshing API as well as the geometry API. Now, the meshing API has the ability to pull things like node and element connectivity from meshes, and you can query some things. The previous API, it was still easy to use, but the performance to get this information, it was just too slow, and it hindered our power users from the ability to do this very rapidly, very quickly. So things like node and element collections and API retrieval is much faster. Now, also in the geometry side of the house, we have the ability now to do high performance geometry tessellation. Now, this is using the visualization toolkit, which people tend to call VTK, which is an open source data visualization toolkit that allows for realistic rendering. Well, what can you do with realistic rendering? Well, let's say you're building a brand new ship or a brand new airplane or a brand new car, and you are probably 6 to 12 months from even thinking about going to the machine shop and actually building things. You might not even have decided on which material suppliers are going to supply the material, nor have you even built the tooling that is going to build your car or your airplane. Now you have the ability to, straight out of Apex, build a realistic render of your model based on the mesh that you have on your part. And you can do things like you can embed a 3D model into your PowerPoint slides. You also can take a static image and place it over top of some sort of landscape or a road or a sky or any type of that. Maybe you're out at sea and you have a brand new ship design that you want to put on a dock image or something like that. You also can upload a 3D model to a web page if you'd like, and just send users a link or customers a link of what your product is going to look like, and they can play with it and rotate and pan and zoom and stuff inside of a web page. That is the power of the VTK toolkit. Okay. Now, other than that, how are users actually applying this Python technology? How are they using it today? Well, let's talk about some practical applications. There's 3 major families of Python scripts that customers have been using Apex for today. We have power tools, you know, and the description is like the comparison is, well, you can either use a screwdriver or you can use a power drill, right? Power drill is much faster, and you would only use that power drill if you have, like, say, more than 5 or 6 screws that you want to screw into something. Maybe you have hundreds that you want to do the same repetitive process over and over again. Well, that's where power tools come in, and Python helps you do those things for the FEA workflows. Now, the second one is in green there, and that focuses on workflow macros. Let's say you have a 3 or 4 or 5 step process that it's the same time, every single time. You want to import your geometry, you want to do a very specific mesh, you want to do a very specific property assignment, and then you want to prepare it for an Astran run. That's just one small example. There are many. Well, taking that small example, and let's say your geometry almost never changes. You want to use that exact same chained ABC workflow. Well, now Python can support that via a workflow macro. And then the third family is interoperability. Let's say you want to use, maybe you're jealous of the ability for Apex to pre and post process MSC Astran, and you want to pre-process a mesh for Mark, or maybe you want to pre-process a mesh for Abacus or LS Dyna. Well, that is where interoperability comes in. You can use Apex as a pre-processor and connect the model to other tools and solvers so that you don't have to manually translate that technology, okay? So some examples of this is let's just look at power tools. You know, things, the ability to import your material database, things to automatically calculate mass properties of your part, things to find and label things. Let's say you have a very large assembly and you have one small edge that's preventing it from being solid. I've used this one lots of times. Thank you for the gentleman that actually made that Python script. We find it very useful here at MSC. And then automatic fastener connection. Let's say you have a part that takes, you know, 300-400 fasteners, and you don't want to click on each fastener hole one at a time for the top and bottom of the fastener. Well, Apex can automatically find those holes that are a short distance away and automatically create fasteners. It's pretty cool. Now let's talk about that second category, which is workflows. Now this is the chain step kind of process. And the examples of this, and by the way, all of these scripts are available for you guys, and they're completely free. So if you want to start messing around with Python and you want some examples of this, please feel free to contact us, and we'll give you an example so that you can start scripting to your heart's desire. Now, an aerospace example is, let's say you're building a brand new wing of an airplane, and maybe it's changing sizes a little bit, but the CAD never changes. You always have surfaces, you always have lines, but you want to just very rapidly get back to the envelope Astran calculation. Well, you can use conceptual modeling for that workflow so that you don't have to manually build these FEA models step every single time. Sometimes a new aircraft goes through a brand new CAD model, sometimes every week or two. And that can be very tedious and time consuming when the design team is waiting for feedback from the FEA team. And the same concept applies for cars and ships and trucks and everything around the world that a human interacts with. Now, the other thing is that maybe your design doesn't exist in CAD. Maybe your design is so brand new that it only exists in Microsoft Excel. Maybe it's a spreadsheet model, like the satellite that I've imaged here. Well, Apex now has the ability to read that data from Excel and build your FEA model directly from that Microsoft Excel sheet. And not only that, but if you can go back and change some values inside of Excel, let's say I want to make my satellite a little bit longer, a little bit shorter, a little bit wider, I can do that by just changing the values, and the workflow API will automatically update it, okay? And then finally, let's talk about interoperability. Now, these are things like, let's say MSC is a powerhouse of solver technology, right? We have Mark, we have Actran for acoustics, we have Cradle for CFD, we have Patran, our legacy pre and post processor. But all of these things can take advantage of Apex, including third-party solvers like Abacus and LS Dyna. You can actually take the mesh directly, and the entire process of building a model inside of Apex, you can interface with all of these different solvers and all of these different tools, okay? So an example of that is, let's say you want to go to a Nastran Sol 400 model, okay? Well, you define maybe glued contact, which is now a mesh independent tie inside of Apex, and you want to translate that to touch and contact. Well, you can do that inside of Apex via the Python scripting technology. You also, maybe you want to do an acoustic or a fluids analysis, and you want to take advantage of Apex's meshing capability. You can do that as well. And the same thing goes for everything else that's listed here as well. Okay, so in summary, we've got pre-processing, we've got user interface, geometry, and mesh updates. The big thing there was now we have light mode. You can have light meat or dark meat at Thanksgiving time, whatever your family wants. You got it covered from the FEA standpoint, at least. Nastran interoperability, we've got contiguous mesh, post-processing, we've got reaction forces, and just zippier, faster import-export technology. And then the Python API, we've got just power tools and workflow automation and interoperability. Our API has grown to the point where some really useful technology has come through. All right, well, at this point, I'm going to stop talking, and I'm going to pass it over to Mitch and see what kind of questions that we got out there in the audience.
Yeah, thanks, James. And like I'm always happy to see this. It's always good to see the new functionality, and it makes me very excited. I'm very happy about it. So thank you for going through that for everybody. There were a lot of questions, but before we jump into that, I wanted to just plug our Apex beta program. We had a tremendous number of people helping us out with the pre-release of the product, testing out the new functionality, trying to find any issues before we go commercial with it. It was a great help to us, and it's been a great opportunity for our customers to get a look at what's coming out before the general market does, and try the new functionality, and also have really direct contact with our development team around what we've been developing, where we could be going in the future. And if anybody else is interested in participating on that, feel free to reach out to either James or I, and we'll make sure your name gets added on that list. So looking forward to having another great beta program for our next release here as well. Okay, so if I start to look at some of the questions, I think probably the first one that came up, and I think officially it was asked before the webinar even started, so I'll start there. And it was, it specifically was, will Apex have all the tools that Patran does? And I think, to answer that, be a little bit specific and answer that question specifically, I would say no. And I think the answer to that is for two reasons. One is Patran is a very rich product that's been on the market for over 30 years, and no one would be able to implement every single one of the features that's in there. And I know many have tried. So that's the first part. And the other part is it's a moving target. Patran development is ongoing, and we continue that way. So to answer the question specifically, no. But do we expect Apex to be your workhorse for CAE? And the answer to that is yes. We are actively working with customers, many of you on the call, to figure out ways to solve the important problems that you have today and what you see coming up in the future. So feel free to reach out to us, contact us, and share your information. We're actively trying to make this your go-to workhorse product. And like we saw today, we're on a very fast release cycle. And so you're going to see new functionality rolling out on a regular basis. Very exciting about it. And like James mentioned at the end there, we have a lot of scripting capabilities as well. A lot of our customers have started to do similar things that they were doing in Patran, like with Patran PCL. But having access to Python and all the utilities that it provides, like you saw with the access to the VTK product as well. You have quite a bit at your fingertips with Apex already. So very excited about where this is going as well. All right, so getting into some of the more technical questions. One of the ones I'll throw over to James is, can you talk a little bit about mesh controls and like specifically, the mesh seed that we have in Apex? Is there a quick, 5-minute or 20-second discussion you can give on that?
There is, and this is something that we can definitely go more into detail via a demo. Really, it really matters. It boils down to what type of mesh that you're using, whether it be hex meshing or TET meshing or shell meshing or beam meshing. We have very specific tools that allow you to dial in that mesh, and this is really what's going to separate Apex from the other pre and post processors that are out there on the market today, including our legacy tools, Patran and Mentat and all the other ones that interact with meshes. You will see a lot more dials and knobs to dial in your mesh to your heart's content and make it look exactly the way you want it to than other tools that are out there. Now, I will also plug the fact that all of the default options are debated about internally before they're actually delivered inside of the Apex product. So you will see a lot of default options where you're like, oh, well, I wanted to dial it in, but it just automatically did it for me. Things like fastener holes, right? A lot of our models have fastener holes, and what do we do the very first time we mesh a part? If it's not an Apex, we create a washer mesh around that fastener hole. So the default option was just decided a couple of releases ago that we said, all right, look, for every single fastener hole, we're going to create a washer mesh just by default, and it's just going to automatically happen there. And you're really not going to see that in any other tools.
Great, thanks,
so
James.
hopefully that was 20 seconds. It might have been a little bit longer.
That's perfect. I know we're coming up to the end, so we're doing a little bit of rapid fire. I'll take the next one, which was what's the release date for 2020 FP1? That one's easy because it came out this past Friday. So everyone should have access to that now. So if you have any issues, please reach out. And then the last question I think we'll probably want to just kind of get a little quick introduction on as well was, it was around the orphan mesh workflow. And how does that work? How do we get the the properties from the original model to the new geometry?
Good question. And this, along with the other questions, because I know that we're not going to have enough time to address all of the questions, but everybody that asks the question, whether you've already asked it or whether you're going to ask it, feel free to continue to ask us, right? You can contact us. I don't think I have my email up here, but it's just james.pura@mscsoftware.com. Feel free to email me your questions and I can answer it, or Mitch also. We'd be happy to answer them via a live demo or something like that, including this question on orphan meshing, right? We can take an entire 2 or 3 hours to talk about all the details and the nitty-gritty of what it takes in order to build a full orphan mesh workflow. But at a high level, basically you're importing that Nastran bulk data file. Let's say you want to make a change to it. Well, in order to make that change inside of Apex, you need geometry. And you need the ability to do things like push and pull and drag and change a mesh and remesh a mesh without having the original geometry. So you need to back calculate that geometry, whether it be solid or surface or shell or anything. You can back calculate that geometry using the geometry for mesh capability. And then just like normal, like if you had the geometry to start with, you would go in and you would do things like defeaturing and changing and pushing and pulling and everything that you already know and love in Apex. Now is supporting because you just did that one small little operation, which is taking the mesh and back calculating the geometry from it, and that's our high level solution to orphan meshing.
Great, thanks, James. Yeah, and like James said, there were a lot of questions. I tried to get to all of them. If I wasn't able to, we'll definitely follow up with you. These are being recorded and shared with us, so we'll make sure that we reach out and answer anyone's questions. And it sounds like there's some other things that we'll have to get to as well. So looking forward to speaking with you in the future. And that's it for the questions.
Well, thank you, Mitch. With this concludes the What's New presentation. Thank you very much. Thank you, everybody, for joining. And we'll be sending out the recording to everybody that registered, whether you attended or not, momentarily within the next day or two. Okay. Thank you, everybody. Take care. Bye-bye.